the details associated with the previous example, which involved coming up with the t-distribution, and this distribution right here, which results in the f-distribution. The details associated with those two derivations are given in the book. They are just outlined here. So here's another example. Let x1 be chi-squared k1 and x2 be chi-squared k2 be independent random variables. Find the distribution of the ratio of x1 to its degrees of freedom divided by x2 to its degrees of freedom. Once again, if you draw the pictures in this case, x1 and x2, since they are both chi-squared random variables, here's x1 and x2, script A will be the first quadrant. Now, in this case, we are interested in y1, which is the ratio of interest right here. If we let y2 be just x2, then script B in this case, here is y1 and y2, will also be the first quadrant. There is a one-to-one transformation from script A to script B, so when you go into all the work of finding inverses, and then finding Jacobians, and then finding the joint distribution, and then finding the marginal distribution, that's the lots of work, and again, this is given in the textbook. You get this distribution right here. This is the PDF of y1, which is the ratio defined up here, and that is known as the f distribution with k1 and k2 degrees of freedom. So this can be written as y1 has the f distribution with k1 degrees of freedom and k2 degrees of freedom, and this is still another distribution that is used in classical statistics, so you'll see quite a bit more. So if you look at the normal, the chi-squared, the t, and the f distribution, they do a lot of the heavy lifting in classical statistics, and you'll see that in the class that follows this one.